Hi, I'm Professor Wilson Kamami. Welcome to our first class on calculus. We shall look at differential calculus, where we shall look at simple rules of differentiation. And with simple rules of differentiation, we know that we shall look at polynomial as our first lesson, where the first rule is where we have constant rule. What do we mean with constant rule? It's a situation where if you are given a function where it's a constant, or what we call a polynomial of degree 0, assume you have y is equals to 6. So if you are to differentiate this one, where you have to get the first derivative, change in y over change in x, where sometimes we use y prime, you get is equals to 0. It means that if you are to differentiate a constant, automatically you get 0. So this, we shall get more examples on this when we proceed, because the second rule, we have the second rule, what we call power rule. So in this case, we are assuming we have our function is x to power n. Is that we are using a general equation. So you are given a function is x to power n. How do we differentiate this one? If you want to get the first derivative of this one, we say that you bring this n there, then it will be x to power n minus 1. The power, you must raise 1 from our power so that we have the derivative of this one. Maybe we can take an example on the same. So assume you have been given y is equals to 3x. No, let me use another case. You are given x to power 6. How do we differentiate this one? So if you want to get the y prime, or what we call change in y or change in x, the gradient of that one, so it will be 6, then x to power 5. We said, first of all, you bring this 6 here, then your power will be x to power, now 6 minus 1. So you get 6x to power 5. Assume you are to get the second derivative of the same. So again, you will bring this one here. So you have that x to power 4. Because we said you bring this here, so you have a product of 6 and 5, you get that. Then your power, we must raise 1 from our power. So it will be x to power 4. So this is how we differentiate constant value, how we differentiate a power number. Now, let's proceed to the third rule, where we shall look at where we have a constant product rule. So now, we are looking at constant multiple rule. This is a situation where you have a combination of constant and power rule. Assume now you have been given your function is cx to power n. How do we differentiate this one? If you are to get the derivative of this one, if you are to differentiate this one, we treat constant the way it is. So in this case, it will be cn x to power n minus 1. So with this case now, we can take an example. So if you are given y is equals to 6x cubed, so how do we differentiate this one? We treat this one just the way it is, a constant. If you want to get the first derivative, how do we get this? You bring this 3 here, so you have 18x to power 2, because we said whenever you are differentiating your x to power n, you bring n there, so it will be product of 6 and 3, so you have 18. Then x to power n minus 1, so it will be to power 2. Maybe we can take another example, example 2. So if you are given y, or let me use this time f of x, a function of x is 6x. You have to differentiate that one again. So the first derivative, how do we differentiate this one? Remember, this one is the same as 6x to power 1. So if you have to differentiate this again, you bring this one here, so you have 6x to power 1 minus 1, where we will have 6x to power 0. And we know any number raised to power 0 is equals to 1. So automatically you get 6. So whatever you have like y is equals to 4x, you have to differentiate that one. To get the y prime, you always get 4. Whenever you are differentiating 4x, you get 4. Whenever you are differentiating 6x, you get 6. 10x, you get 10. But I think with the clear illustration why we are getting 10, how we are getting 6, how we are getting 4, is by the fact that this was x to power 1. When you less 1, it will be x to power 0, and any number less to power 0 will be equals to 1. So we now have what we call sum rule. When it comes to sum rule, let's assume we have two differentiable functions. If we have f and g, and these two are a differentiable function, how do we differentiate? So we are differentiating two functions, addition of two functions. So this is just the same as differentiating each. Then you get the sum. There's no big deal about that one. Is that such that we have the derivative of two functions, which are combined by a sum sign, addition sign. So with this one, you can differentiate this one by itself, then you add the derivative of this one by itself. So how do we get this one? It's just simple example. Assume you have that one. So we want to get the first derivative of this one. How do we get the derivative of this one? We differentiate this one by itself, then we add the derivative of this one. It's because we have here, we may assume we have a function f of x, and here we have a function g of x. So if you are to solve this one, you differentiate this one by itself, then you add the derivative of this one. So how do we differentiate 3x power 4? I know based on our previous example, you can be able to solve this one, where you bring 4 here, you get 12, then x to power 3, because we said you must less your power with 1. So you get 12x to power 3, plus, how do we differentiate 4x? We said automatically you get 4, where I explained this was x to power 1. So when you bring 1 here, you get 4, then x to power 0, because it was 1 minus 1, it will be x to power 0, and any number is to power 0 will be 1. So that's how we get the derivative of this one. The same case will apply if we had a negative sign. So let's look at difference rule, where now we look at our fifth rule, which will be just the same case with this one, where we assume now here we had a negative sign. The same case will happen with this one. So regardless of addition or subtraction sign, if our example remains the same, but in this case here we have negative, the answer will be negative 4, because we are differentiating this by itself, then we minus the derivative of this one by itself. So in case we have now the sum or difference rule, now if we have difference rule, it won't have much impact compared to addition. So with that one, you can be able to solve even example 2. Maybe you have your y. So with that one, we can be able to get the first derivative, what we call dy over dx. So if we are to get this one, we solve this one by itself, where we shall get, it is 8x. We know how we are solving it, that one. You bring 2 there, it will be 8, 4 times 2. Then x to power 2 minus 1, where we get x to power 1, you get 8x. Minus, we said when you are differentiating 2x, you get 2. Plus, when you are differentiating a constant, we said when you differentiate a constant, automatically you get a 0. When you differentiate 2x, you get 2. Because this was x to power 1, when you less 1, it will be x to power 0, and that will be 1. So that's how we get the derivative. Maybe you can proceed to get the second derivative. You solve this one, you get 8, because when you differentiate this one, you get 0. So it will be 8 minus 0, where there is no need of writing that one. When you want to get the third derivative, you get 0, because when you differentiate 8, you get 0. So if you have your y, you can get first derivative. If you differentiate your first derivative, again, you get the second derivative. If you differentiate your second derivative, you get your third derivative. So that's why we use sum rule or difference rule. Let's proceed to our fifth rule. I have combined sum rule with the difference rule. So let's proceed. I hope by now you can be able to see that these mathematics are not hard if you get this basic concept. So you need to start from this basic concept, because if you want to proceed to differential equations, ordinary differential equation, partial differential equation, you need all these basic things. As you can see now, we are looking at product rule. And in product rule, it's just the same as what we had in sum and difference rule. So in this case, we are differentiating a product of two differentiable functions. Remember, there must be we are having two differentiable functions. So we want to differentiate the product. So in this case, if you want to differentiate the product of two differentiable functions, you treat one function as constant, then you differentiate the other. So in this case, I'll treat my function f as constant, then I differentiate my g of x, my function g. As you can see, I have treated this one as a constant, so there's no need of differentiating that one. Then I differentiate this function of x. Again, now, I'll add, now, I need to treat now the other function constant, I differentiate the other one. So I'll treat g of x as constant and differentiate my function f, which is a function of x. As you can see, with this one, we are treating one function as constant. We differentiate the other one. Then we add where we treat now the other function as constant and differentiate the first function which we assumed was constant. As you can see, I have treated f as constant, differentiated g. Plus, now I treat g constant, I differentiate f. So with that one, the order doesn't matter. You may start with treating g as constant, then you differentiate f. As you can see with this one, the order doesn't matter. You may first treat g as constant, then you differentiate f. Plus, now, you treat now f constant, and now, therefore now you differentiate g. The order doesn't matter. You may differentiate, and you may start with assuming n is constant. The order doesn't matter, but you realize when you be looking at quotient rule, the order will be very important. So I must put more emphasis on this one, that order when it comes to product rule doesn't matter, as long as you do the right thing. So let's take our first example. Let's take our first example. Assume we have a function x minus 2, product of that one, and x squared plus 1. Assume you have those two products. You are required to differentiate those one. You are required to differentiate our function y. Our function y is a function of two differentiable functions, x minus 1 and x squared plus 1. How do we differentiate this one? Remember, this one, we will treat it as f, and this one, we will treat it as g, a function of x. So, when I want to get the first derivative, or what we call change in y over change in x, the gradient of that one, so you treat this one constant. So I'll treat x minus 1, x minus 2 as constant, then I differentiate this one. Then, since I have treated my f as constant, the next time I treat my g as constant, I'll treat my g as constant, then I differentiate my f, which is x minus 2. I hope this is clear. I have treated f constant, I have differentiated g. Now I treat g constant, I differentiate my f. And now, the answer will be very simple, x minus 2. Then the derivative of this one, remember the basic rule that we have used. If you have this one, it's like we have sum rule. So differentiate this by itself, you get 2x, because you know you must bring 2 there, then x power 1 plus 0, because when you differentiate 1, it's a constant, you get 0, plus x squared plus 1. Then when you differentiate this one, we said when you differentiate 1x, you get 1 minus 0, because when you differentiate 2, it will be 0. So with this one, you can be able to see that you get x minus 2 times 2x plus x squared plus 1 times 1. So you can simplify this one and get 2x squared minus 4x plus x squared plus 1, where you may simplify this one further, and you find that the derivative of this one will be this way. So even though you start by assuming this one now, assume you started assuming this one is constant, you get this one. Plus, now this one. So as you can see, the order won't have any impact when it comes to product rule. So I put this one clear again. First, treat the first function or the second function constant, differentiate the other one. Then on the other, then you add, treat the other function now, the constant as constant, then you differentiate the other one. With that one, we can be able to solve a product rule, which will be much important when you'll be proceeding with more of this calculus. So you need this basic. You need to familiarize yourself with this basic. You need to do more examples on the same, on this one. Maybe we can do another example for more clarification. When you do these more examples, when you proceed, it will be much easier for you to solve even complex equations on the more complicated equation when it comes to calculus. It will be much easier because it will just come to your head that I need to use product rule, I need to use quotient rule, I need to use this rule. So with this one, treat it very serious, product rule. Before we do, let's take another example before we proceed to what we call the quotient rule. Example 2. We may assume any function, assume your y, I love using different y or f of x, any function. So with this one, we may assume you have x cubed. And the other one, you have x minus 1. Or x squared plus 1. We may have where it is a bit complex. So with this one, remember, we said here we have two functions. And these two functions, I may use here h to avoid having the same representation. So we have two functions. And we want to differentiate the two functions, the product of these two functions. Our h is a product of two functions. How do we differentiate this one? If I want to get the first derivative of this one, I'm at the derivative of my function h, I need to hold this one constant, then I differentiate this one. The next time I hold this one constant, I differentiate this one. So with this time, I may hold this one constant first of all. Then I differentiate this one. I said the order doesn't matter. You may first of all hold this one constant and differentiate this one. Like what I'm about to do. Hold this one constant. Then you differentiate my g. So you may start with this one plus this one, or this one plus this one. The order doesn't matter when it comes to product rule. So you treat this one as constant, just like the way we were treating when we had a multiple constant rule, where we treated this one as 6, it was 6x squared, where we treated this one as 6, we just focused on x squared, where we had 6x squared, where you are treating this one as a constant, so you are focusing on this one only. So in this case, I'll have x squared plus 1. Then when I differentiate this one, I'll get 3x squared. Remember, when you differentiate this one, you bring 3 there, then x squared, because your power must be minus 1, then minus 2, because when you differentiate 2x, you get 2. So we have that one, plus now x cubed minus 2x. Remember, we are treating this one as constant. Then when you differentiate this one, you will get 2x. And you know how we are getting 2x? Bring 2 there, so you have 2x to the power 1. Why x to the power 1? Because this was to the power 2, and we said we must raise power with 1. So plus, when you differentiate a constant, it's just 0. So there's no need of writing plus 0. So when you simplify this one further now, you'll be able to get the gradient of that one. So now we can proceed to our sixth rule. where we have quotient rule. Here, we have two differentiable functions. Let me use this black here. Nini. Kind of black it. So in this case now, we are differentiating two functions which are differentiable. So it's a fraction. The other one was a product. So in this case, we are differentiating a fraction. But with this one, again, the order is very important. The order of this one matters a lot, where we are treating one as constant and differentiate the other. So in this case, first of all, you differentiate the numerator. So I treat g as constant, I differentiate the numerator. Get that one very seriously. You differentiate numerator first. So you treat this one constant, differentiate numerator. You must start with that one. Not like the other time we are saying you may treat this one constant and different. No. This one you must start by differentiating the numerator. Then, unlike the product rule where we are using addition sign, in this case we use subtraction sign. So with this one now, it will be now you treat your numerator constant and now you differentiate denominator. And unlike the other one, this one must be over g squared, our denominator squared. I hope with this one is very clear. First of all, differentiate numerator. You differentiate numerator while you hold the denominator constant. Then now, you differentiate the denominator. Remember, you must treat the other one constant. So, I have treated my numerator as a constant. So now I have differentiated what? The denominator. And as you can see with those two is that here we are using negative sign. Subtraction sign. Unlike the product rule where we are using addition. So in this case, that's why you see the order is very important. So you start with the differentiating numerator, then you differentiate the denominator over denominator squared. So with this one now, we can take just a simple example. So assume your y is a function of 3x all over x squared minus 1. So you are required to differentiate this one. There are some people who might treat this one as product rule, because I know, just for the sake, there are some people who might think this is 3x times x squared minus 1 to the power negative 1. But I want, first of all, you know that one, because we want to use the quotient rule. I know there's some people who can use this one and use the product rule, but here you find that there is chain rule somewhere. So let's focus on this one where you are differentiating the quotient, the fraction. So in this case, you want the first derivative. We have said you differentiate numerator first. So I will treat denominator as constant. I differentiate the numerator minus, as we have agreed, the sign must always be negative when it comes to quotient here. Then now I differentiate the denominator. So I will differentiate x squared minus 1 all over now the denominator squared. I hope this one is very clear. We are differentiating first of all numerator, then differentiating the denominator. So with that one, I know with that one, it will become much easier for you now, because here you have x squared minus 1. But when you differentiate now 3x, we said you get 3 minus 3x. Now when you differentiate this one, you get 2x, because it will be 2x minus 0. So you get just 2x all over x squared minus 1 squared. So you can simplify that one further and get 3x squared minus 3 minus 6x squared, where all over x squared minus 1 I know when it comes to simplification, now you can get 3x squared minus 6x squared. So with this one, the order, I'll put more emphasis on this one. The order is key. You first differentiate numerator, then you differentiate denominator by putting the other one as constant. But the sign that separates those two is our negative sign, our subtraction sign, all over denominator squared. That's how we solve quotient rule. We shall look at more examples on the same when it comes to quotient rule. Maybe you can do another one example before you look at our last but not least, our last rule for today, which will be our chain rule. Example 2. On the same, maybe you have y is equals to 6x minus 1 all over 3x cubed minus 2x. I hope it's not related with the other one. So we want to differentiate this one. Again, we said we must differentiate numerator first. So you have 3x cubed minus 2x. We hold that one constant. So we differentiate numerator first. So minus, we say in this case it's not like product rule. We use negative sign. So we hold 6 numerator constant. Now we differentiate denominator all over denominator squared. So with this one now, we just simplify, we just solve our derivative and then we leave it there because I know when it comes to simplification, here will be much easier. So you have 3x cubed minus 2x. Then when you differentiate 6x minus 1, I know based on the previous rules, you can be able to see that you get 6 because 6x you get 6. Although when you differentiate 1, it will be 0 minus 6x minus 1. And another mistake that students you find making this mistake is where they ignore these brackets. When you ignore these brackets, remember when you are opening here, it will have an impact from this negative sign. If you don't put this bracket, you get a different answer because assume there is no negative, there is no bracket. It's like you are saying minus 6x minus 1. But when you open this one, you find that it is minus 6x plus 1. So brackets are very important to that one so that you don't end up missing your marks just because of what we call certain mistakes. So use brackets. So how do we differentiate this one? When you differentiate this one now, you get 9. Remember we said this really comes there. 9x squared because we must less 1. Minus 2 because when you differentiate 2x, we said you get 2. All over 3x squared minus 2x, where that one is squared. So you can go and simplify further. So now we have what we call chain rule. It's our last rule for today. We have what we call chain rule. What do we mean when we talk of chain rule? We are assuming we have two functions in one. Let me use that word. So if you are having a function y, which is a function of u, the variables we have are u, but u is a function of x again. So with that one, we can be able, remember both y and u are differentiable. So we differentiate now y with respect to u, and we multiply when we differentiate u with respect to x. So you have two functions. Let me use two functions in one, even though it's not the right word to use. But with the example, you understand what I mean. So y is a function of u, but u is a function of x. So you can solve them separately, where you differentiate first of all y with respect to u, and u with respect to x, then you get the product of two. Let's take a simple example where everybody, I know with this one, might look simple. So you have that one. You have to differentiate this one to power 7. How do you solve this one? I know a student might think of using now the expansion, binomial expansion to get this one, but before you solve to power 7, you might get tired on the way. So how do we solve this one? With this one, we may assume this one is u. So we will have y is equals to u to power 7, where We know our u, to may assume, is x squared minus 1. I hope that one is clear. We let our u to be x squared minus 1. So my y will be u to power 7. So with that one, we can solve each independently. So in that case, we can get dy over du, the change in y over change in u. So how do we differentiate that one? You get 7u to power 6. I hope that one is clear because my y was u to power 7. So you bring 7 there, then u to power 6. So you have 7u to power 6. Okay, we have solved that one separately with this one. Now, remember again, my u was x squared minus 1. So we can get the change in u over change in x. So we can differentiate this one with respect to x, where we get 2x minus 0. So we call it just 2x. So when you differentiate u with respect to x, this will get 2x minus 0. So you get 2x. So remember now, we said now, my dy over dx will be equals to dy over du, change in y over change in u, times change in u over change in x, where now my change in y over change in u is 7u to power 6, times change in u over change in x, you get 2x. So in this case, you have 7x squared minus 1 to power 6 times 2x. And that's the answer. Because we have replaced our u, remember our u was x squared minus 1. So we differentiated u independently, we got 7u to power 6. So we have replaced our u, where we know our u is x squared minus 1. So we have 7x squared minus 1 to power 6 times now du over dx. My u was x squared minus 1. The derivative of that one, you get 2x. So we are solving them separately. So with that one, you can be able to get the derivative of this one. Change in y over change in x, you will get it is that one. So it's very simple with that one. There are some cases where you solve this one direct. When you become an expert, you'll be solving this one direct. The y prime or dy over dx. It will just be simple. Bring 7 here, you treat it the way it is. You have 7x squared minus 1 to power 6. You see how I've treated this one just like one number. So I upload that one. Then again, I differentiate now inside. I'll get 2x. With that one, it's just the same as that one. So there are some people who will be using it directly. First of all, hold this one as a one number. So 7 to power 6. That one. Then you differentiate inside that one. You get x squared minus 1. Maybe you can take another one example. Here we take our second example on chain rule, where I have made it a bit complex, so that a bit complicated, so that you can be able to see, even though you get a complicated equation, how you tackle that one immediately and get to use one of the rules. So with this one, we know this one is a cube root. The denominator is cube root of this one. So what we are doing with this one, we know that this is the same as 1 over x cubed, x squared. This was x squared plus x plus 1 to power a third. I know by law of indices, you know this is the same as power third cube root. It means the cube root of this one. Again, by law of indices, you can take this one to be a one number. You have 1 times now x squared plus x plus 1 to power negative a third. You take it to be a numerator by changing now the power to the negative sign, from positive to negative and vice versa. So you have now my y is x squared plus x plus 1 per negative a third. So with this one now, you can solve using chain rule. You can solve using chain rule, where you let this one to be u. So u is x squared plus x plus 1. So du over dx will be 2x plus 1. So where we treated this one as u, so now my y became u to power negative a third. Remember, we said we may assume this one to be u. So this one y will be u to power negative a third. So we differentiate that one with respect to u. Change in y over change in u, you get negative a third. We said you bring this negative third here. So it will be u to power negative 4 over 3. Because after bringing this one here, then the power must be minus 1. And when you have minus a third minus 1, you get minus 4 over 3. So now my y, my change in y over change in x, we said it is change in y over change in u times change in u over change in x. So you take the product of this one. Times now change in u over change in x, where it will be 2x plus 1. You just replace your u now. So you have negative a third. What is your u? Your u, remember, was x squared plus x plus 1 to power negative 4 over 3 times 2x plus 1. And that's how we solve our equation. We have treated this one to be u, calculated the derivative of u with respect to x, and after treating this one as u, our y changed to be y is equals to u to power negative a third. Then we solved this one with respect to u, the derivative with respect to u. Then remember our equation was that if you want to get dy over dx, it will be a product of dy over du times du over dx. It is not a must we have u and x. Remember, you may have other variables, but remember the concept is the same. So with that one, that's how we solve our chain rule. I think now it is clear now to everybody that when you differentiate a constant, you get 0. When you differentiate constant with x, like 5x, you get 5. 10x, 10. When you differentiate 12x, you get 12. When you differentiate minus 6x, you get minus 6. It is clear to that one. Then, when you are differentiating a power rule, maybe you are differentiating x to power 7. Bring that 7 forward, then it will be 7x to power 6. Remember, power you minus 1. We looked at sum rule, difference rule. Now we looked at product rule, where we say the product, the order doesn't matter. You treat one constant, you differentiate the other one, then you add the other one. With that one, we looked at the quotient rule, where we say the order matters, but you start by differentiating the numerator before you differentiate the denominator, and then the sign there is negative. We solve that one. We have given an example on chain rule. I know with the chain rule, we will come across more chain rule, like a situation where we'll be solving trigonometry. The next lesson now we shall look at how do we differentiate using what we call the first principle rule. First principle. I know you may find a question where it is very specific. As we agreed now, if you have an equation, don't feel like you can drop your question in a comment section. You can use one of my channel. You have my email there. You have my WhatsApp number there. You can drop a question where I'll be answering questions as soon as possible. Within, let me say, within 24 hours, I will be able to answer you if you have a question, so that we interact together. We help you so that you can understand mathematics. And by understanding mathematics, in the future, you'll be able to help even the other students, because we don't want to kill mathematics. We want to enjoy mathematics together and simplify it, and you graduate and understand what you are doing. More so, it's to understand what you are doing with this mathematics. So let's meet next time, where I shall look at the first principle rule as we proceed with more videos. Thank you for watching.